Ladies and gentlemen, please welcome our next speaker, Lovisa Johansson, presenting the topic, Real-World Examples of Message Queue Usage, Insights from RabbitMQ.
Hi everyone. I'm really glad to be here. It's been nice days. I've seen a wonderful city of Vilnius and have really great conversations. I hope you're feeling okay after yesterday's get-together and that this session will not add any post-party headaches for you. Since forever, we have communicated. We have used all sorts of communication methods. We have called each other, texted each other via SMS, even used carrier pigeons and smoke signals. In the tech world, the situation is similar. Communication methods constantly evolving, including the increasing use of message queues. A message queue is just like a waiting line in the store, but for information, tasks, or messages instead of a waiting line for people. A queue opens up the possibility of easy scaling, just as when there is a new checkup opening at the grocery shopping and you become really happy. You can add more services to your system and become really happy because the data flow is increasing, because these new services can help out clearing the queue. On a beautiful day, when you go out for a run, you might be running with a workout application. When you've completed this run, you check the leaderboard, see if you set a new personal best on the course you ran. And the IT architecture in Adidas training app Runtastic is divided into different parts, various services are working together behind the scenes, and these services could be tracking the run, it could be updating the leaderboard, or it could be displaying the route you have been running. Building each service in this architecture is usually the easiest part, but most time you need these parts to communicate and need to coordinate them. And this is where threads of complexity start to unreveal. As far as communication in especially microservices goes, two popular approaches graces the stage. We have asynchronous HTTPS and synchronous HTTPS and asynchronous lightweight messaging. Even though HTTPS might seem simple at first, it has some downsides. Because of its synchronous nature, it requires immediate response to every request that is sent. But in reality, every request doesn't need an immediate answer. So if you think about the leaderboard in the workout app, it doesn't have to be finished the exact same moment as you have completed your run. To be able to handle millions of users, the communication in between the services at Runtastic takes place via a queue, also called a job queue, message broker, and in Adidas case, through RabbitMQ. When the gym closed during the COVID-19 pandemic, a lot of more people started running, and the use of workout apps increased a lot. Queues in this case helped lining up the tasks, these running tasks. So even if a lot of more people started running all of a sudden, the data was just waiting in line and couldn't be handled when convenient. Now you could close your eyes for a second and think about New York City, the non-stop city where everything happens and the sound is shouting all the time. Here we have relay delivery, which fits right in as a food delivery service, with cyclists navigating the street with a phone in their hand, trying to find your door so they can deliver the food to them. In the heart of relay delivery, we have RabbitMQ, of course, that takes care of everything in all the communication they have. Relay delivery and Runtastic are just two examples of how message queue can be used for internal communication in microservices. But as we have seen, RabbitMQ is also used in legacy system integration. We have seen it being used when you manage work queues, when you need to stream data, when you need to enable RPC communication, in IoT architectures between Raspberry Pis and your backend, and so on. They're endless. We have seen also that RabbitMQ is used almost everywhere in society. So I will show you a video. Maybe it could be nice to have it on full screen. No.
I bet she doesn't know. It's kind of cool that she doesn't. What am I talking about? Well, the infrastructure used by her workout application to send and receive data. And it's not just this one application. In fact, thousands, even millions of users benefit from it daily. The bank, the food delivery service, or the retail app that sends confirmation emails seconds after purchase. The use cases are endless. And the key to all this is called message queuing. Highly scalable, built to handle it all, from when data is created until it reaches its destination. Ask yourself, is your infrastructure ready for an increasing number of users? Is their data handled safely, and can they count on your application working effortlessly to give them what they need? If providing high-quality service is at the top of your mind, message queuing and RabbitMQ should be too. Because even if she is just one of thousands going on a jog at that exact time, all she cares about is that her app is working.
So now I will do a short introduction of who I am, why I'm standing here. Then I will talk about RabbitMQ, a little bit about AMQP, the AMQP protocol, and I will combine this and mix this up with some real-world use cases. And it stopped working. What did you say? Control Shift. Go back. Ah, perfect. So a short recap of everything. Here. So my name is Lovisa. I'm from Sweden, and we love queue and ordering. That's why I work at CloudMQP, where we provide RabbitMQ as a service. I love also kite surfing. This is where I kite surf in the north of Sweden, in Umeå. Need a big wetsuit, but I also been in Spain, Brazil, Philippines, Morocco, and so on. It was my biggest interest for a really long time. I have dogs, chickens, and also 2 kids, which take a lot of time now. The youngest is 8 months old. Probably, or maybe you saw him yesterday. He was here mingling around. I've been involved with RabbitMQ for many years. I have helped out on Stack Overflow. I have written hundreds of blogs around RabbitMQ and even 2 books about it. I've also tackled plenty of support questions, or thousands of support questions. I've also helped out building a training tool for RabbitMQ. How many in here have used or are using or are familiar with the message queue? Wow, that's a lot. Nice. So I will start out with a use case where a message queue is really handy, and it's when you need to make sure that background tasks are reliably completed. So imagine that you have just built an application for rentals of houses, so apartment rentals, and you want landlords to upload information of the apartment to this app. Sadly, a lot of landlords upload really high quality images, and your app becomes slow, so you decide to handle the resizing of this high quality images, and you've chosen to use a message queue here. to prevent the app from crashing if many landlords are uploading a lot of images at the same time. So here we have the base architecture of a message queue. We have the publisher who adds an image scaling request to the message queue. Then we have a subscriber on the other side called image service that takes the message from the queue, scales the selected image, and adds the image to the website. When this app is growing, more and more people start using it, and even more people are uploading images at the same time. You can add more image scaling services that will help clear the queue and so increase the data flow of your system. RabbitMQ is built on a protocol called AMQP, so let's delve a little bit into that. The default protocol is AMQP 0.9.1, which specifies both over-the-wire protocol and how clients and the brokers should behave. In order to be compatible, it has to live up to a few rules regarding how messages are routed and how they are stored in the broker. And the protocol is also very specific on how connections are made and, for example, how you should declare a queue. Other defining features are reliability, like acknowledgements, and security, like encryptions and authentication. So in AMQP, you first have something called a connection. It's what you set up between your service and the queue. This connection takes care of underlying network tasks like IP resolution and authentication and things like that. Within this connection, you can set up something called a channel. And a channel is like a virtual connection, but when you use a channel, you forego the need to reauthorize and open a new TCP stream, which makes it better you use your resources more efficiently. And this setting up connections instead of adding channels is one of the most common errors our customers are doing, which takes down their server. RabbitMQ also simplifies routing cases compared to other messaging systems like Kafka. So you can routing makes sure that a message can reach a specific queue without your need to add an additional code to all this. So messages in RabbitMQ are actually not published straight to a queue. They go through something called an exchange. And you can think about an exchange as a mail delivery post desk, ensuring that the message will end up in the correct queue. So messages are then routed depending on bindings in between the exchange and the queue. And apart from the main content in the message, you also have a routing key and a set of headers, and those headers could include like expiration time. RabbitMQ comes by default with 4 different exchange types. We have the direct exchange, the fan-out exchange, the topic exchange, and the header exchange. And I will try to explain those by using the example with the post office. So imagine you come into a post office and you're going to send an email or a message. Then you have 4 different options to which desk you should go to. So if you go to the direct exchange, you take your message, you write the name on the envelope, and you hand it over to the desk. They check on this name and gives the message to the person that needs this envelope. Super easy. Here you can think about the name as the routing key and the person receiving the message as the queue. So for the direct exchange, it goes directly to that person. Then we have the fan-out exchange. Here you come into the desk, to the fan-out desk. You give the letter to the person standing there. This person takes this letter, makes a copy of it, and give it out to all persons in that post office area, regardless of what you have written on this email. So it's almost like spam or something like that. Then you have the topic exchange. Here you come to the desk, you give the letter to the person behind it, which looks at a category or a topic on the mail. It could be, for example, if you want to send to the development department in a company, you write that as a category. It takes this message and sends it out to all those people subscribing to exactly that topic. And then finally, we have the header exchange, which is kind of similar to the topic exchange, but instead it looks on, we could pretend that you look at on a stamp on the envelope and sort the email out of that instead. It sorts on headers. Oh, I forgot the topic exchange. If we go back, it's also pretty smart. It can use wildcard matches and combine them with patterns and send emails, send messages like that. I would like to direct our attention to the topic exchange because it's the one that holds a specific I think it's really good, and that's the one we use the most. So here is an example of how we are using the topic exchange. We work with, as I said, our software as a service for RabbitMQ, but also for LavinMQ. What we do is that when someone buys a server, RabbitMQ cluster or server from us, we set up, we buy this from Amazon or Google, set it up in their cloud. We set up RabbitMQ, configure it as the customer wants us to configure it, automatically, or of course. And once this server is up, we want to notify a lot of other services in our system about this successful task. So what we do is that we add a message to the topic exchange, and we have many services subscribing to this completed, finished setup server message. One of these is the server metrics, which in turn sets up, does a connection to the newly created server and start to receive server data like CPU or disk space and so on. Another of these services is the RabbitMQ metrics, which does the same thing. Takes the message, sets up a new connection to this newly created server and start to receive RabbitMQ specific data, which makes it possible for us to set up alarms and stuff like that around RabbitMQ. And all these new services can simply just subscribe to the messages without the first service needing to know about what are other services doing with my data that I'm sending away. Adidas Runtastic is taking advantage of the same type of routing. Here you can see that, or do you remember that they subscribed to the leaderboard service that updated leaderboard? So here they send a message that the run is completed, and other services just subscribe to that completed session and handle the data. So we can imagine that we are doing a new training app that will evaluate the run session that you just did. So all they need to do is all you need to do is deploy that service, connect it to the queue, and you will be able to just keep going. We keep moving to something else. Messages in transit might get lost in case of a connection failure and need to be retransmitted. AMQP is very clear on when responsibility is transferred from one part of the system to the others, and this is done via something called acknowledgements. So you can confirm that a message has been successfully transferred or processed once it's sent out, or when the service wants to say, now I'm finished with this, so you can move on. So an explicit acknowledgement. If a consumer cannot process a message for some reason, your desired outcome could be that you want to requeue it to let someone else take care of that message, or that you want to process it in a later time. However, your message will stay safe in the queue in the meantime. And once an acknowledgement is received, it's discarded from the queue. Many of us are probably doing backups of databases. This is usually a long-running task. It takes time, especially if you have really huge databases, or thousands of databases, which we have had. So here we do like this. We add a database backup request to the message queue. Then we let a backup service take care of this backup, do the backup of the database. The queue holds on to the message until this backup has been completed and is then acted and removed from the queue. And now you might think, what happens if we have like we have a database as a service, for example, and we have scheduled thousands of databases, and all of a sudden you want to let your customers do a backup by an API or something like that. Luckily then, RabbitMQ supports something called priority queues. So you can let this message that this triggered via the API, you can let that go before all other messages, because it will have a higher priority, and then it will be consumed before all the other messages. We move over again to something else. This is dead lettering. It's the key part of almost any messaging system out there. Some messages might be undeliverable or unhandled, even if they are received by the broker. And this can happen when the amount of data a message has spent in the queue has been exceeded, or when a queue reaches its capacity. And then or when it's negatively acknowledged by the consumer. And such a message is then called a dead message. Setting up a dead letter exchange and a dead letter queue let you handle this, because you can take care of these orphaned messages, and they can be stored and processed again from the dead letter queue. Using a dead letter is very beneficial in, for example, e-commerce system when you take care of order processing, because this dead letter can handle message that can't be processed after that can't be successfully processed after a certain amount of times, and this will take care of unexpected payment processing failures. And after that, of course, the administrator or someone else can take care of this message and check what's wrong with it, how can we make this not happen again, and yeah, that's it. There is also use cases where you have unroutable messages, like if you send a message and there is no binding set up between a queue and an exchange, for example. And here you can decide if you either want to silently drop this message or send it back to some other queue. Here comes a use case from a logistic application that takes care of RabbitMQ for order fulfillment. An alternate exchange is set up alongside the order status. So if a message can't be routed for some reason, with an invalid order status, for example, it can be handled directly from the alternate exchange as a safe, fail-safe measure. And so far, I've mostly talked a lot about queues, but I haven't said much about them. So here comes the main queues in RabbitMQ. It's classic queues, quorum queues, and streams. Quorum queues and streams are the most interesting one, so those are the two we'll focus on now. We start with quorum queues, which come in handy when high availability and data safety is non-negotiable. So each quorum queue here is replicated. You have a leader and you have several followers known as replicas. All client interactions go through the leader, and the leader is responsible for replicating various commands to the followers. And the follower itself doesn't have anything to do with client interaction. It's simply there for pure redundancy. If a broker becomes unavailable, another has to step up. And quorum queues, they have their name because all operations like message replications and leader election and so on require a quorum, a majority of the replicas to agree. Streams is the most recent added queue type to RabbitMQ. It's primarily designed for other use cases, like large fanouts or when you need to have multiple consumers, amongst others. And the key features here is that stream queues can read the data multiple times without being removed from the queue. And this is something that not all brokers have. ActiveMQ doesn't have support for this, but of course it comes from Kafka, which makes RabbitMQ a really good alternative if you are working with an RabbitMQ environment, but you want to add Kafka-like features into RabbitMQ. It's good when you need to process a message multiple times or from a lot of different consumers. While so far I have talked about AMQP mainly, I want to mention that RabbitMQ is a multi-protocol, extending its support beyond AMQP. It does also have support for MQTT, STAMP, HTTP, WebSockets, and so on. And you can choose the protocol that align best with the technology that you are using. For example, a lot of our customers are using MQTT in Internet of Things. And while talking about MQTT, we have an example from FarmBot. This is an open source farming robot that you can have in your garden, which can watering your plants and taking photos. It can even scare the birds away. This application, or this robot, has sensors and drivers which bridge the connection between your physical garden and the software layer that you have, or they have. A message broker is used for messaging between the database, the user, and the devices in the system. And we can see they are using MQTT from the Raspberry to the broker, while they are using AMQP in many other parts of their architecture. In the early days of the internet, we had web pages. They were static, like digital brochures. Later along came dynamic content with server-side scripting, and that enabled personalized interactions. And as the need for real-time interactions grow, finally WebSockets came along, and they changed the game, enabling two-way communication between client and server. And RabbitMQ, among other message brokers, have support for WebSockets, which is ensuring a robust and scalable real-time communication. Here we have an example from Visman. I'm not sure I pronounced that right. I hope so. But they are leading industry in the heating and cooling system, and they are using WebSockets and RabbitMQ together when they do, for example, for their live update feature. So they let messages from the heating system go through RabbitMQ, through the WebSocket, and end up in their front application. So they can receive real-time updates from their system. We will move on to RabbitMQ, how it's used. The main use case, I would say, for RabbitMQ is within microservices. Here we have Parkster, a parking app company in Sweden. They divided their software into a collection of small isolated services where each service can be deployed and scale as needed and function independent of each other. By breaking down their app, they gave developers the freedom to use whatever technology they wanted for different parts of the system. And this means that one part can evolve independently, be written in different programming languages, or maintained by different teams. And we at CloudMQP, we do the same. We have most of our applications written in Ruby, some in Crystal, some in Go, and so on. And we have around 100 of microservices communicating through our own queues, because we are also using RabbitMQ in our own architecture. So even if one of these services goes down, if part of the backend is delayed or broken, the whole app could still be working. So even if, in this case, you parked your car and you think, yay, the payment service is down, you will still have to pay, because the message will stay in the queue and be handled when convenient, or when the payment service is back up again. Many of our customers are sending thousands of emails, even handling email automation services. Tack. And they, of course, if you have an automation service, you have to send campaigns with, and you can have changing demands. Sometimes you send a little bit, sometimes you send a lot. And by adding a message queue, you can kind of decouple the production of your emails to from the service that actually sends the email. We are using message queues for this, of course. We send our mails to the message broker and let email services take care of this. Trust is another company. They work with, they let your company find if you have like a product you want to sell, you find the influencer to that product. This influencer is supposed to write a review of your product. So in different stage, they have to send a lot of emails to all of these candidates that should be able to give you a good review of your product. What they did is that they decoupled they had a monolith synchronous application. They broke it up into pieces and are now using asynchronous messaging and are sending much more messages per second. Another company using RabbitMQ for microservices is Rever, which work with a workflow solution for manufacturing. So their workers could be standing on the floor reporting safety hazards, observations, or even if they have an improvement idea for the company, they can improve it directly through their phone. And the whole their system is built with a message queue as a ground in our infrastructure, and they are sending hundreds of thousands of messages through this system per day. To keep up with unpredictable command, we have multiple retailers using RabbitMQ, mainly because they can scale when needed. Like when it's Black Friday, they could bump up the servers pretty much, or they can add more consumers to the servers and make sure that orders are efficiently and quickly processed. There are also many taxi and delivery firms using us, sending all their data as they are constantly sharing GPS data through our systems. We have also one of the largest breweries as a customer, and a newspaper or many newspapers that add their articles to the queue and take care of them after that. And one of these newspapers is a newspaper with 65 million readers a month. We have one of the world's largest payment solutions and several of the world's most famous car brands as customers. And it's so interesting because in my job I get to travel to these customers, talk to them, and either help them set up their infrastructure with a broker in the middle, or just talk to them and see how are they using us and how is a message queue used. And again, it's very clear to us that message queues are used everywhere, as I said, in society, government, retail, education, and of course for different use cases. It bridges communication in your infrastructure. It's used with streaming, IoT as a general pub sub message broker, and so on. So now, when I have talked a lot about this, you might think, when should I not use a message queue in my infrastructure? And I would answer like someone in the European Parliament. It depends. Depends on what goal you have with your architecture. But in most simple use cases, you don't need a message queue, and it's easiest to exclude a message queue early in your development process. But when you build or aim to build large, complex, interconnected system, or when you know that you will have a need to scale, then the need for a message queue will come sooner or later. So from what I've seen, or what we have seen, is that it's easier to implement a message broker early in the process than to try to add a message broker when already a lot of data is flowing around. Ironically, you need a little extra complexity to handle more complexity. I have not covered all the features in RabbitMQ. Shortly mentioned Federation Shovel. It's when you can set up servers in different clouds or different regions in the clouds, and you can let data flow between them. You can also do clustering. You can set up 1, 3, or 5 nodes and combine this together. And you can shovel messages from one server to another. There are features like that, and there are much more features, and you can come to our booth. We are outside if you have any questions, and we will try to answer your questions or help you if you are working with RabbitMQ and need some help. Finally, I want to tell the 3 things I think you should remember from this talk. And what I think is the best things with using a message queue. Firstly, it's that you improve scalability. It enables seamless integration. You can easily add additional consumers when there's a peak hour or when there's a sudden need for more capacity, like during the pandemic and a lot of more people started to run, or, as I said, during Black Friday. Reliability and fault tolerance. The introduction of a message queue fosters asynchronous communication, decoupling your services, which enhance reliability. So, for example, in an event of a failure, like when the payment service was down in the parking app, other services could continue processing without destroying everything else, or everything else could continue working. And lastly, flexibility. Message queue facilitates loose coupling, so you can implement new changes or new feature without having to interact with the whole system. You can write in different programming languages if you want, and so on. Like in the training app, if you wanted to do this new service that evaluates your run, you could easily just set it to the connect it to the queue and start to receive those messages. Yeah, thank you so much for listening.
Thank you a lot for your talk. Very informative, I think. And we have a very heated discussions and a lot of questions. So let's see how many can you answer. So let's start with the awarded one. How availability and data replication work for Rabbit? You touched briefly on this, but I guess you can elaborate a little bit more. If I send a message and a Rabbit node accepting it crashes, what are the scalability and high availability models?
You can set up, like I mentioned a little bit in the end, you can set up clustering, so you can have 1, 2, or 3, 5 nodes or more. But if it crashes, it depends on what you have done. If you're using quorum queues, you have one answer. If you're using classic queues, you have a really bad answer. Then you should change away from classic queues and shift to quorum queues, because it's much more stable, and we really recommend it. If you have classic queues, you can mirror queues, which you can mirror the message from one queue to another. And if you have quorum queues, you replicate the messages. But classic queues have had problem with crashes, because when you mirror and if the node goes down, they start to synchronize, which could be make your node go down for a really long time, which is, don't use the classic queues.
Okay, don't use the classic queues. Next question. You said that you were operating on MQP version 0.9, and apparently there is a higher version available. Why don't you use that?
0.9.1 is one protocol, and AMQP 0.1 is a completely different protocol. The name are alike, but they are behaving completely different to each other.
So it's a breaking change between the major bits?
Yeah, but there is support for AMQP 1.0 as a plugin. And in version, the next big major version in RabbitMQ 4.0, 1.0 will be much more involved.
Okay.
But they didn't change it because it's not the same protocol, despite
Damn it,
the name.
major updates. When would you suggest to use Rabbit over Kafka and vice versa?
I would say that I would always suggest RabbitMQ. That's a bad question. No, we have actually been hosting Kafka for a really long time as well. And we suggested all people that are this is my most answered questions on Stack Overflow. I have so many points from this question. When you send a large amount of data that needs to be streamed, I think you should go with Kafka. And general pub sub message broker microservices, RabbitMQ.
Gotcha. What are the benefits of fan-out exchange comparing it with a topic exchange?
I would say that the fan-out exchange will kind of, when you have the streams, you can, if you're doing really large fan-outs, I think you should do a stream instead, because it will be just one message sent out to a lot of them. The fan-out is easy. We are almost only using the topic exchange because it's really good for us. But do you know when we use the fan-out exchange the most? Tough question. The
Come
best
to see,
benefits. I
our speaker at
will
the
think
booth.
about it to find the best benefits for it.
Alrighty, then next one. How to configure, or is it possible to configure queue or message to have a special message as a blocker? So if the message is not acknowledged, next message will not continue to process.
Yes, if you send a message you can either send a bunch of messages or you can send one single message. So I guess I'm not 100% sure, but if you have just one single message and you send it, and then you block it until you have acknowledged it, but then you have I don't remember the name of this, but if you can also decide to send like 10 messages or 100 of messages to each consumer and let them handle that and then acknowledge that back. But if you just send one, you will only send one. But then you also have the problem that you might have many consumers. So if you send one and you have more consumers, of course more messages will go out because it will try to process messages as fast as possible. So one consumer and only send one message at a time. Then it will work.
Is it something like circuit breaker maybe in RabbitMQ that says, oh, this message was not properly processed, I do not accept anything until the problem is resolved on the consumer end?
No, because the RabbitMQ will always try to send out the messages. But if you have one consumer, then it will work.
Okay. Next one. How do you handle Rabbit upgrades and or migrations without downtime? Bonus question, how do you deal with Rabbit version being dependent on Erlang version?
I start with the second one, Erlang version. Actually, we built a new message broker because RabbitMQ is dependent on the Erlang version, because we have so much trouble trying to find employees for that can work with Erlang. We have, thankfully, Erlang solutions, which helps us a lot with consultant hours around Erlang. But we built another message broker to be able to not. But maybe that's not the question. Is it around Erlang updates?
I guess so. So basically, do you have problems with language? You said yes, not too many employees.
We love Erlang and we love. But how we handle upgrades and migrations, we are doing this in different ways. I can give a huge description of that in the booth, but I don't think everyone else will listen. But Erik, he's a professional on our migration from one version to another. We are using a lot of federation and we are swifting in and out disks and so on.
Okay, for a more detailed lecture on this, please visit Rabbit booth.
He's our support engineer.
Okay, let's have two more small, I hope, blitz questions. Do the stream queues have support for something similar to Kafka's consumer groups?
I don't think so. Correct me if I'm wrong.
Again, open to a discussion afterwards. And the last one, who owns the cloud service, you or the customer? And who can access message content stored on this service?
We can access it if we want to, but we are not allowed to because we don't do that. We have written contracts that we shouldn't use it. The cloud service is owned by AWS. We buy them and we set up the infrastructure, but usually our customers are in the same cloud and we use VCP peering to those servers.
Gotcha.